Question 6 starts off with a difference equation. So there's this population and it's increasing by 1.2% each year, but X people emigrate each year. So they're using a difference equation to model this. And it assumes that emigration occurs at the end of each year, which is quite an important detail because there was a similar thing to this on last year's exam. And I didn't mention this point, which meant that there were actually technically 2 correct answers. So I'm going to show you why that's important, but we're going to do the question first so you can see why. And then it just gives us the initial information. Write a difference equation. Okay. The population in the next year will be 1.012 times the population of the previous year minus how many people emigrated, which is X. So that's 1 plus the 1.2% increase minus how many immigrate. The reason this is important is because you could equal last year, if it didn't say that, which it didn't last year, now it wasn't exactly the same, but it was similar, you could have written something like this and it would have been equally valid. So this means the 1.2% that's the increase is on the population after the people have emigrated. So we have the population, the people emigrate, and after the people emigrate, then it increases by 1.012. But because they emigrate at the end of the year, what actually happens is the population increases and then the people emigrate. So that's the important difference there. And I'm glad that they mentioned that this year because it was quite ambiguous last year. And then they told us to solve the difference equation to find Pn in terms of n and x. If you watch my difference equations video, you'll know that I use the exact same method for all difference equations. So our particular solution is the first one we do. And that's going to be just the constant part. So Pn, our particular solution. So ignoring all the Pn's here, we just have a constant. So our particular solution will also just be a constant, which I'm going to call A. That means our particular solution for the n plus 1th term is still just a constant A. Now we can sub into our original difference equation. We get A equals 1.012A minus X. So that was just replacing the P ends with an A. Then we can bring the X to the left side and we get 0.012A. That means that A is equal to 250 over 3 times X. Or you can write it, you can write it as X divided by this, but that's kind of messy. So you can convert it to a fraction like this. That means, we just parked that there. That's our particular solution. This is our particular solution because that's our complementary solution now. So remember this to find the roots of the characteristic equation. We take the lowest Pn to be a constant, the next one to be a root, which I'll call OR because X is already taken, and then the next one up is an OR squared. But here we just have 2, so there's only 2. So we'll have OR to the power of 1 equals 1.012 OR to the power of 0. And then if there was a Pn plus 2, that would be our OR squared, but which you'll see in one of the later questions about second order. So this is quite self-explanatory. OR to the power of 0 is 1. So our root is 1.012. That means that our complementary solution is equal to alpha times 1.012 to the power of n. Now our final solution will be equal to the sum of the complementary solution and the particular solution, which will be equal to alpha times 1.012 to the power of n plus 250 over 3x. I know it would be tempting to put that down as a minus since it's the people emigrating, you'd think, but just trust the method. Our particular solution was A, and A was positive 250 over 3x. Okay, now we need to find out what alpha is because they said in terms of n and x, not in terms of alpha. And we're told that P0 is 13,500, so we can use that fact. P0 is equal to 13,500, which is equal to alpha, and then this to the power of 0 is just 1, so we have plus 250 over 3x. That just means that alpha is going to be equal to 13,500 minus 250 over 3x. That means that our final answer, Pn, is given by, so instead of alpha, I'm writing 13,500 minus 250 over 3x. Multiplied by 1.012 to the power of n plus 250 over 3 times x. And if you did it with a different method, your answer might look slightly different, maybe because this will be expanded out, and then this 250 will be factored with this one, but it should overall, if you expand it out and simplify, you should be able to get the same thing as this. Then they tell us some more information and tell us to find out what x is, so P1 is 13,514, so P1 is equal to 13,514. That's the same as replacing all the n's with a 1. So we're going to have, again, just for the sake of time, I'm not going to write it again, but of course you would in the exam. I'm going to copy this down. We're replacing that n with a 1 because it's the first year, n equals 1. We need to multiply that 1.012 into both of those. So we get that 13,514 equals, so we'll have 1.012 times the 13,500 will give you 13,662 minus, and then the 250 multiplied by the 1.012 will give you 253. So 253 over 3x, and then we still have the plus 250 over 3x. Now, we'll bring the constant to the other side, so we'll do 13,514 minus 13,662. We'll get minus 148 equals, and then minus 253 plus 250, that'll be minus 3 over 3x. Or in other words, minus 3 over 3 is just minus 1. So minus x, that means that our x is equal to 148. That's our value for x, number of people emigrate each year. Then we need to calculate the predicted population at the start of 2029. So we can add 7, because year 2022, that was 0. 2023 was 1, which is a year after 2022. So if we want to go 7 years after 2022, that'll be 2029. So we say that P7 equals, we might have to rewrite our difference equation actually, just to simplify it a bit. Pn equals, so our Pn is equal to this, right, as we know. But now we know what x is, so we can actually simplify this a little bit. So x is 148. So I'm going to replace this x with 148. I'm going to replace this x with 148. And now we can just simplify it, and we can just plug straight in, but actually we'll just plug straight in because it's actually quicker than rewriting it all out, and time is obviously a big thing. So we're looking for P7. That's going to be 13,500 minus 250 times 148, which is our x, over 3 times 1.012 to the power of 7 plus 250 times 148 all over 3. You can just put that into your calculator and you get an answer of 13,601.59. Well, 0.6 if you round it technically, but it doesn't matter because this is a population. You can't have 0.6 of a person, so we're going to round up to 13,602. You might be tempted to round down because you can't have 0.6 of a person, but in the marking schemes, they always just round mathematically, and in this case, we mathematically round up. That's what they do in the marking schemes, so that's what you want to do. Although, would they actually punish you for it? I don't know. Maybe if you explained that you can't have 0.6 of a person, they wouldn't. Even if they did, it would be -1 mark for just rounding. But yeah, they usually round up in the marking schemes. Next up is a differential equation. So this messed a lot of people up. So it's just a acceleration modeled by this differential equation. So we need to get the v's onto one. Before we worry about anything, let's get the v's onto one side and the s's onto the other. So we have our v dv. Let's divide across by that e to the power of v squared over 4 equals, bring the ds up, we get ds. Now, just to make things a little easier to see, I'm going to bring that up to the top of the fraction by writing it as v e to the power of minus v squared over 4, just so it's a little easier to work with, equals ds. And now we're going to integrate both sides. Before we worry about the integrals, let's look at the limits. V is 0 when s is 0, and they go up to some velocity v and end at some velocity s. Okay. A lot of people have jumped straight to integration by parts here. Now, the first thing you should always do is check if it's in your log tables, because there are some very complicated integrals that you can't do with techniques that could just be in the log tables. This one isn't, though, I'll tell you that. And after you try that, you should next try substitution. You shouldn't go straight to integration by parts. That should be your last resort. Substitution. In this case, even if you're not following those steps, you should notice the derivative of v squared is 2v. Or, in other words, it's going to have a v in it. The derivative of this has a v in it. So when we substitute this and we get a v as our answer, we could cancel that with this v. So that should be kind of making you want to try substituting for this. So that's exactly what we're going to do. Let's let u equals to minus v squared over 4, which means that the derivative of u with respect to v equals minus v over 2. That's just taking 1 away from the power and multiplying by the power. So that's 2 over 4 is the same as a half, and the minus is still there. Now we need to get rid of this dv. Let's solve for dv. So we get that du over v times minus 2 equals dv. What did I do there? I brought the dv up there, I brought the v down, and I brought the 2 up there, and the minus also went with it. Now we can rewrite our integral, the integral of 0 to v. Another important thing to note, these limits are only for when we had the v's here. So make sure we're turning them back to v's before we sub in the numbers. We can't sub in these numbers for u. So we're going to have v, e, and then this power here, that's just our u. So we're going to replace that with just u times, and then instead of dv, we're going to have minus 2 du over v. Minus 2 du over v. And as I said, because the derivative of this has a v in it, this v will cancel out this v, and it works out quite nicely. Equals the integral of ds is just s from 0 up to s. Now we continue. So these v's will cancel. That's pretty nice. This minus 2 we can take out the front because it's a constant. We're multiplying by minus 2, so that doesn't actually affect the integral, and it makes it a little easier to look at. So we have e to the power of u du. And that's a v up there, by the way, not a u, equals, and then we just have s minus 0. The integral of e to the power of u is e to the power of u. So we have minus 2 e to the power of u. Again, we're still evaluating that from e to v equals s. Now remember, we can't plug in straight away. These v's, these limits were for the v's. So we need to replace this u with a v before we can sub in. So we have minus 2 times e to the power of minus v squared over 4 between 0 and v. Now the reason I've written the minus 2 out the front, I factored the minus 2 out, is because that's not going to affect this, and it's going to reduce our chance of making an error. So you'll see, I'll show you now, we sub in v, we get e to the power of minus v squared over 4. That was horrible, what the hell. V squared over 4 minus e to the power of 0. Now what a lot of people do is normally when you're doing the limits, you do the first one, e to the power minus v squared over 4, minus the second one. So what a lot of people would do is they'd put down this one minus this one and keep the 2. They'd say, for example, 2 minus 2, and they wouldn't have this here. But the thing is, the second one should actually be a plus, because we have this minus here, and then the minus here will turn it into a plus. That's why it's nice to take out any constant multiples, and then do it, and then multiply them back in, as we have here. That's equal to s. Now what we'll have is we'll have minus 2 e to the minus v squared over 4, plus, and then that's going to be 1. Minus 1 times minus 2 is just 2. That's equal to s. So we have minus 2 e to the minus v squared over 4 equals s minus 2. When we divide by that minus 2, we'll get e to the minus v squared over 4 equals, I'm going to flip those around, we'll have 2 minus s over 2. So I brought the minus down, and then I distributed it by flipping these signs. We need to get v by itself, so let's take the natural log on both sides. And then that'll cancel with the e, so we'll get minus v squared over 4. I don't know why I put the 4 there. Equals ln of, we'll have 2 minus s over 2. Finally get v by itself, we'll have v squared equals minus 4 ln of 2 minus s over 2. Finally, that means that our velocity is given by the square root of minus 4 ln of 2 minus s over 2. And that is our answer for the velocity. Finally, we're told to calculate the velocity when s is 0.3. So it's going to be velocity equals the square root of minus 4 ln of 2 minus 0.3 over 2. Put that into your calculator, and you get that it's about 0.81 meters per second, because its velocity is meters per second, and that's the answer.